now we're going to actually learn how to put down positions on a scale like this, because it's not as easy as doing it on a normal paper chart. So we'll put down a position, we'll plot a course, we'll measure a position, and we'll measure a course. So just go through all the 4 types of things you would need to be able to do. I picked 23 degrees 15 minutes north, 84 degrees 30 minutes west as our DR position we're using in this theoretical problem here. So that's our first step, is we're just going to set up that position. Our degrees are easy because we see right here 23 degrees north. I don't know how visible that is for you, but 3 degrees north. And we know that 84 degrees west is here. So we're somewhere left of this line and north and above this line. We're in this general area. So we're going to start with the latitude, 23 degrees. We need to come up to 23:15. So we're marked 10, 20, 30. Here's 15. So we're just going to, there's a couple different things you can do. You could just mark a little spot there. You can mark a little spot in the middle here. What I like to do though, is give a nice clean line across. It doesn't need to be dark. Just swipe it across so that you have the whole area. Because now we need to measure the longitude. Remember, we're 84 degrees, 30 minutes west up here. So we come down to our longitude scale. We have 84 degrees already, so we just need the 30 minutes part. So here's 3, here's 0. Measure it like that. There's 30 minutes of longitude at our latitude that we've chosen. So you come over here. You go from where your line intersected 84 across, mark that point. And that right there is our first position. You can then erase the extra. You should use one of those bigger white erasers. You shouldn't use a pencil eraser, at least not the pink ones, because they leave stains. If it's white, it's better, but it's still like, it's considered good practice to just use a full-size eraser, not this. But I don't have mine with me right now. So here's our point right here. Now we said this was a DR position, so we got to set it as a DR position. And then I never wrote a time, but obviously to have a DR position, you always need a time with it. So let's just say 0800. Good. Nextly, you've got to plot your the course we're going to be following off of this. So I think I said, yeah, we're 230. So just like when we're plotting on paper charts, you come to a meridian. You can use one of the ones you made if you trust yourself, and I already double checked it, so I know that this is accurate. And you measure an angle of 230. Make sure the window stays directly over the meridian, and then the meridian passes through 230. There we go. Where's my other triangle? Here it is. Slide that down. Remember, this could be 230 or the reciprocal, which is 050. But you know, we're going down this way because we're going southwest, so we have to plot it in that direction. And then we would label that course 230 degrees true with an arrow. And I never gave us a speed, but let's say speed 12 knots. So that's how you would set up your starting course and everything, your DR position for a universal plotting sheet. Now let's say you need this position right here. For whatever reason, you need to know what the value of that point right there is. Well, you work everything in reverse. Actually, it's not even really in reverse. First, start with the latitude. I always think it's easier to start with the latitude. draw a quick line across. That way you can measure quickly. We got 31, and we're still in the 23 degrees. So that could be 23 degrees, 31 minutes north. Shouldn't normally write directly on it, but I don't have another paper to write on. Then you measure this longitudinal distance right here from the point to where you had it intersect the meridian. You bring that down, set it up, and now this is where things get a little more complicated, because you can see it doesn't fall exactly on the 30 and the 0. And if you bring it to the 20, comes into the 1s area. If you bring it to the 10, it goes over. So what you have to do is you have to pick the 10s value that keeps it within the 1 section here. So we have to bring it to the 20, find where it lands, and you can see it lands right between the 8 and the 10. So this is equivalent to 29 minutes because we've got 20 and 9. We measured that. That's 29 minutes from here to here because west goes this way. Meaning that has a position of 085 degrees, 29 minutes west. Now let's say you need to know what course that is, and let's say it's going that way. This is exactly the same as paper plotting. You just measure it out like that, line it up, make sure the window passes through the meridian, drop it down, and you can see it lands 125, 126, 127, 128. 128 degrees true. Okay, so realistically, the only thing that's different about this compared to paper chart plotting on paper charts is the longitude scale. Instead of having a longitude scale across the bottom of the page like you would on a paper chart, it's shifted off to the side here, and you have to bring all of your measurements that are east-west over there to measure off of. Latitude works the same, and courses work exactly the same. If we wanted to do the same thing here, we just got to remember we're in the south. So our latitude is 57 degrees, 20 minutes south. Oh wait, I'd already flipped it over. 57 degrees, 20 minutes south. And we know our longitude is 22 degrees. So we've got the 22 here. So we're working somewhere over on this side. Now 57 is right there. We need 57, what did I say again? 20 degrees. Okay, so we're 20 minutes south of this 57 degree line. Now we could measure the 20 right here, but it would be a pain to shift that over. So instead what we could do is measure out 20 minutes. Like that. Bring it over here. Mark that point. And then draw it out just like we did before. I think I picked a bad parallel to set 57 as, because we're probably going to end up as on the bottom of the page the whole time. If I had put it up here, it would have been a little bit better. But whatever, it's not the end of the world if it's down here. It's just a little less convenient. So then we had a longitude value of 22 degrees, 45 minutes. So we need to measure out 45 minutes here. Set 1 point on the 40. 1 point halfway between the 4 and the 6. That gives you 45. And what I should have done is I should have continued this line all the way until it hit the next degree value. Didn't do that, so I have to extend it a little further. There. Now I can reliably place this down. Oh wait, no, I'm wrong. 'Cause we're in the east, so we're going this, so east increases this way. So I actually have to extend it in the opposite direction. 22 degrees 45 would be over here. So we place here and there, and we get our starting DR position. And and again, let's say that's 0800. Now we need to set up our course. We're going with 087. So we can place the window here. Remember, we don't need the triangle to be facing down like this. It can face up and work just as well. We bring it over to 87. Slide it down so it's perfectly in line. And then plot that across. Shift a little bit. Like so. Course 087 degrees true. That way, speed 12 knots. Okay. And you can see I did the longitude right, or I actually could have shifted it over a little bit more. Where I should have put this is I should have set this as 57 and this as 22. And that would have put us and here going like that, which just uses the maximum optimal amount of space across the page. This was a mistake on my part to put it down here. It's still fine. We're going to be able to plot with this without a problem, but had it been up here, we would have had more room.